Okay, I wanted to add a little bonus one into 15.2, finding the inverse. This here is called an exponential function. Okay, exponential function. And it is one-to-one. It's that red function there, and it might not be perfectly drawn if you type it into Desmos, but this is an exponential function, and right now, I'm teaching from home because of the coronavirus, and so you probably saw this a lot when they were talking about the coronavirus and how it was spreading. But since this is a one-to-one function, what we can do is we can say, well, let's let that be y is 2 to the x, and then I can interchange the x and the y. And so when I do that, okay, when I do that, the precise moment that I do that, this is technically, this here is the inverse, okay? But over time, because just standardized rules, they said, well, you have to solve this for y, okay? Now this is something we've never done before. We've never solved for y in the exponent, okay? Now maybe back in grade school, or elementary school, you could have solved something for an exponent if it was an easy problem like 5 to what power equals 25, okay? And there you could say, well, it's 2, all right? But, how do we isolate y here, okay? Now, some people try to divide by 2, and there's a lot of different things to do, but this is where we have to introduce logarithms to be able to get this y isolated. And we're going to do a lot more with logarithms this chapter, but to write a logarithm, what you do is you write log, and then this is the base, so I put that as the base of the logarithm. And then this, since it's on this side, I always remember if these two are together here, the exponent actually goes to its own side, and then this comes over here. So this is red, log base 2 of x is y, okay? Or you could say y is log base 2 of x, all right? So this is now solved for y, okay? So how do we know that that's the truth and I didn't just make that up, okay? Now what you could do here is you could type this into Desmos, okay? Type this into Desmos, and what you'll see is you're going to get a picture here that kind of looks like this. And I'll try to draw it well here, but you'll get this one here that's the exponential function. And then here you're going to get, if you type in this log base 2 of x, you're going to get this logarithmic function. Okay, so what's the inverse of an exponential function? The inverse of an exponential function is a logarithmic function. And what you'll notice is both of the functions are one-to-one, okay? And they reflect about this line y equals x. So what I recommend typing into Desmos is these 3 things, okay? So first type this in, okay? Then type this in, okay? Then type this in, and what you'll notice is these 2 are actually on top of each other because that's just in 2 different forms, okay? And then just for visual effect, I would type in the y equals x, okay? That'd be the 4th thing I would type into Desmos because then you would get this line of symmetry, okay? So why do we have to study the inverse function? Well, the inverse function leads us from this one-to-one function that's the exponential function into a new method where we have to solve for an exponent, and then solving for an exponent leads us into this idea of logarithms, okay? So what's the inverse of an exponential function? A logarithmic function. What's the inverse of a logarithmic function? An exponential function. Okay? That wraps up everything in 15.2 2.